So today we're still looking at graphs of these polynomials, and we're picking out specific sections where the graph is either increasing or it's decreasing. And the way we're going to write our answers is using what's called interval notation. We're going to write our answers in intervals. Basically, when you have a graph, no matter what it looks like, and we've done this a little bit with domain and range or in quadratics, but if I want to talk about this section of the graph right here, how do you say that? You can't just list out random numbers, because there are literally infinitely number of points in this section. Okay, so we use intervals. We have like parentheses, we have our starting number and an ending number. So an interval is a range of numbers between two values. So when I have an interval, I'm saying this is my starting, it starts doing whatever I say and here, and then it stops doing whatever I say here. So your first number is your starting, your second number is your ending. You use an interval when there are too many numbers, I think that's what goes there, too many numbers to list separately. So this will be a number, and this will be a number. And we use intervals for lots of things. What we're doing today is just one of the things we use intervals for. So, increasing and decreasing. A function is increasing if the y values get, what do you think?
Higher.
Bigger, higher, yep. If the y values get larger as you move from left and right. A function is decreasing if the y values get smaller as you move left to right. Basically, if you're looking at the graph and you're tracing it with your finger, if your finger goes up, it's increasing. If your finger goes down, it's decreasing. When we list our intervals of increasing and decreasing, this is very, very important. We only list the x value. So basically, we're going to have an interval with our starting x. So where does it start increasing or decreasing, whichever? That's going to be a number. It's just your x value. And then the ending x. If it starts at an arrow, it's going to be negative infinity to something. If it ends on an arrow, it's going to be something to infinity. So if you're, like if we're looking at the graph, and once we actually get into an example, it'll seem a little, it'll make more sense. But at our polynomials, we know go forever in one direction. So we can't really pick a starting value. We saw this with domain and range when we did quadratics, or we did something. But you will put infinity there. If it's on the left, it's negative infinity. If it's on the right, it's positive infinity. So what we're going to do is we're going to graph this function. And when I ask you to graph, here's what I expect you to do. I expect that you find the maximums and minimums and plot those points, and then you can just kind of sketch in the rest of the graph the best you can. But I do expect that you at least look up the max and mins, which you can do the best on Desmos. So x cubed, you can get your Chromebook out if you want, minus 3x squared. So before I draw in the graph, I'm going to plot and label my max and mins. I want you to label the point on the graph. So 0, 0, and 2, -4. And if you can get those 2 points in, and then your sketch will be fairly decent. Alright, so on my graph, if I were to take my finger or whatever and trace this, right here, I notice I'm going uphill. So would I say that this section is increasing or decreasing? Increasing. So right here is increasing. So I'm going to have an interval. Where do I start increasing? At what point? That's where I end. So we're going kind of left to right. Where do I start? Negative infinity. There's an arrow there. Yeah, I start on the arrow. So if we actually pull this up on Desmos, right here, I'd be like, okay, where do you start? Oh, you're going to keep going forever. Right, so it starts on negative infinity. Okay. That is the farthest. Now here, you got to be careful because it is pointing down, but it's also pointing to the left. So the left is kind of what we care about. We care about x's, so we care about left to right. So it's negative infinity because it starts on the left. Okay, and then I get up here to this maximum, to this hilltop. That's where it starts. Remember, we only are writing the x's. So at what x value does it stop? What is it? 0. So it increases from negative infinity to 0. And then what happens? Once it decreases. Good. So this section is decreasing. Where does it start decreasing? At what x? 0. And it stops at 2. And then what? It increases. Yep, these graphs, they'll go back and forth. It'll be, they flip-flop. Increase, decrease, increase, decrease. So from 2 to positive infinity. So it doesn't necessarily, and we'll see some other examples, it doesn't necessarily matter if it's pointing up or down. If it ends on an arrow, it goes to positive infinity because it's going to the right. So we're going to keep doing some examples. Right, so number 2, y equals negative x to the 4th plus 4x squared minus 2x minus 1. So this example has 2 maximums and 1 minimum. Remember, your maximums are your hilltops or your mountaintops. Your minimums are down in the valleys. And I want you to start by graphing those. And it helps, it 100% helps if when you draw the point, if you write that point down over here. Now, I'm okay if you round to just 1 or 2 decimal places, because that'll really, a lot of numbers will really start to get jumbled up. Okay, so we have negative, so negative 1.5 is halfway between negative 1 and negative 2. And then I go up almost 6. Your points, I mean, you don't have to have your point like perfect. So this is negative 1.53, 5.94. If you round correctly, if you were rounding to 2 decimal places. And I click down here. I've got 0.26, negative 1.2. Just get it as close as you can. Missed my number there, 2.5. And then we've got, oops, not that one. There we go. 1.27, 0.31. Alright, so if I start tracing out this graph, am I going to be increasing or am I going to be decreasing? If I start and I trace it with my fingers, my finger going to go up or down? It's going to be going up. So you kind of ignore the end arrows like on this part. So my finger or whatever I'm tracing with literally goes up. So that's increasing. So where does it start increasing? Negative infinity, because it starts, there's an arrow on the left. I don't say negative infinity because it's pointing down. I say negative infinity because it's on the left. It's pointing to the left. And then where does it stop? Careful, negative 1.53. Yep. Remember, we only, on increasing and decreasing, we only care about the x values. So once I'm there at the top, then I'm going to start coming back down. And that's going to be decreasing. So where does it start decreasing? Negative 1.53. And then it stops at 0.26. And then I'm going to go back up just a little bit from 0.26 to 1.27. And then I end up decreasing. And where do I start decreasing? 1.27. And I end where? Not negative infinity. Positive infinity, because it's pointing to the right. It also is pointing down, but that doesn't matter. We only care left or right. Notice you kind of, if you start at the very beginning and you go your way through, you start at negative infinity, and then it's like this interval ended at this negative 1.53. This one picked back up there. And then it ended at 0.26. That one picked back up there. And then you end with positive infinity. So you should have an interval for most all the time that has negative infinity to start on the left, and your very last one should end with positive infinity. And then, you shouldn't really have any missing numbers anywhere. Like you stopped at the 1.53, you pick back up at the 1.53. That should basically be the same thing you do with all of these examples. They won't always start with increasing. They may start with decreasing. All right, number 3. Y equals x cubed plus 2, plus 2x squared minus 4x minus 1. Oops, I messed that graph up. Oh. If you have not been here the last couple of days, most of the graphing and stuff we do is a lot easier for you to do on Desmos. And when you type it in, all you have to do is click like on the graph and kind of hover over those points, and it'll tell you what those points are. It is much easier to do that on Desmos than it is to do that on our 84s. Alright, so I am going to start. My first interval is going to be increasing or decreasing? Increasing. Goes uphill. Uphill, uphill. So where do I start? Negative infinity. Your very first interval should always start with negative infinity. And then where does it stop? Negative 2. Be careful. And now that I'm at the mountaintop or the hilltop, I'm at my maximum, then I'm going to start going downhill. So I'm starting going downhill at negative 2. And then I stop where? 0.67. Good. And then I go back up. From 0.67 to infinity. Your first interval should start at negative infinity. Your last interval should end with positive infinity. Any questions? Alright. Number 4. Y equals x to the 4th minus 4x squared. Nope, forgot my x. X squared minus 2x plus 3. Everybody getting these graphs? Does this graph start with increasing or start with decreasing? If you trace it, your pencil going to go downhill or uphill first? Downhill. So decreasing, downhill. Where does it start decreasing? Negative infinity. Yes, it's pointing up. That's not what I'm looking at. I'm looking at the fact that it points to the left. And left, it very subtly goes to the left, but it does. Left is negative infinity. And then it stops at where? Negative 1.27. Very good. And then now I'm in the valley, so I'm going to go uphill from negative 1.27 till I get to the top at negative 0.26. And then I go downhill again from negative 0.26 to 1.53. And then I go back uphill. 1.53 to positive infinity. Yep. I want you to work on those last 3 by yourself, and then I will show the answers up here. Alright, so check your answers for numbers 5, and then we'll do 6 and 7.
My infinity sounds like really good compared to yours.
Oh, yeah, when I read that, I didn't know what you put earlier. When I checked one of yours, I was confused, and then I realized it was
Now, like rounding wise, you need to know how to round. However, on test, a range of answers will be allowed. So as long as you're like really close. Like I'm not going to take negative 0.9 as opposed to negative 0.67, but I will take negative 0.6 or negative 0.7, anywhere between.